Hello and welcome back. In this video, we're going to discuss how to determine the distance between a point and a line in space. In these examples that I'm working through, Q will be our point that's not necessarily on the line, and L will be our line. And we want to know what's the distance between Q and L. I think the first thing to talk about here is how do you define the distance between a point and a line? And for that, we take the shortest possible distance, right? There's a lot of different line segments we can draw from Q to L. So maybe, for instance, here's my point Q, and here's my line L. There's lots of different line segments I can draw from Q to various points on L, right? And they'll have different lengths. So what's the distance? The distance is the length of the line segment that is shortest from Q to L. And that'll happen precisely when that line segment is perpendicular to L. So that's the idea, is we want to get a hold of the distance of this line segment where we travel from Q to L perpendicularly. Okay, so let me jump to a figure in our text here, just to sort of illustrate this and get at how we're going to come up with the equations. I'm going to turn that off for a second. So let's see. So here I have my point Q, which is not on the line in this case. So I have a positive distance between the point and the line. And then I have my line L here. So what do I know about this line? Well, I know given a line, I can recover points on the line. So if I have a vector equation of the line, I know a direction vector, that's my v, and I know a point on the line, that's my p naught. So I can always recover those two pieces of information. Really, for this, we just need any point on the line will work. So any scalar multiple of r naught plus r naught plus any scalar multiple of v will work. So any point on the line will work. Here I'm going to use a t value of 1, so this point on the line, so not my fixed point down here, but just p. And the deal is I can find the vector pq, which goes from p to q, my point that's off of the line. And then I want to draw a perpendicular from q to my line. So that's pictured here dashed. That's my perpendicular. So how do I get a hold of this the length of this perpendicular line? Well, remember that, or just rather use some geometry here, or some trigonometry. If I have the angle between vector PQ and my direction vector of the line, if I have the angle of those, then this is just getting from a trigonometric formula. This would be magnitude of my hypotenuse, which would be my vector PQ. So magnitude of PQ times sine of the angle between them. I'll go ahead and turn that back on. That's this. And that actually works with any point on the line. Any point P that I pick, if I compute magnitude of PQ times sine of the angle between them, that gives me the length of this perpendicular line segment, which is what I want. So again, any point on the line works. Pick your favorite P on the line, find the vector PQ, find your direction vector V, and then if we can find the angle between them times PQ, we'll have the length and therefore the distance between the point and the line. Now this magnitude PQ sine theta actually is a little bit familiar. So I'm going to jump into making that, because again, we don't want to have to find the angle between our two vectors. It's not a fun process to find that angle. So is there another vector operation we can use here? That's the question. So let's try and work that out. I'm going to jump back to the whiteboard here. So the idea that we got from that that figure, that interactive figure, we had a point P on the line. We had Q, which was our point we're trying to find the distance to. So we wanted to find the length of that line segment, the perpendicular to the line. And so we worked out, that the distance, d, was the magnitude of PQ times sine theta, where theta is the angle betwixt, or between, the angle between PQ and our direction vector of the line, v. All right, so this is interesting. This PQ sine theta should look familiar. Remember that if I do PQ cross V, remember that the magnitude of PQ cross V is magnitude of PQ times the magnitude of V times sine of the angle between them, the same theta. So, if this is the distance, I just need to divide this magnitude of the cross product by the magnitude of V, and I'll have magnitude PQ times sine theta. So that is D, my distance, a scalar, is equal to magnitude of PQ cross V divided by magnitude of V. And that will work out to be PQ sine theta. But remember, this is going to be much nicer because we can compute cross products really easily by computing determinants of matrices. We don't have to mess around with finding this angle between them. We can do it all by just using the cross product, the magnitude of that, divided by the magnitude of V. And so that's going to be our main route for finding the distance between a point and a line. That's it for this video. In the next video, I'm going to work through an example where I actually compute the distance between a point and a line. Hope to see you there.